I am S. Kirtana. My topic is cloud storage and resource replication. Introduction to cloud computing. Cloud computing is a technology that provides on-demand access to computing resources through the internet. Users can access these resources whenever needed without owning or maintaining physical hardware. The main computing resources include storage, servers, networks, applications. Storage is used to store and manage data online. Servers are powerful systems used to run applications and process data. Networks are enable communication and connectivity between systems. Applications are software that can be accessed directly through the internet. All these resources are delivered over the internet, which means users do not need to install or manage them on their local machines. Cloud computing follows a pay-as-you-use model, where users pay only for the resources they consume. This makes cloud computing cost-effective, flexible, and scalable for individuals and organizations. What is cloud storage? Cloud storage is a service that allows users to store data on remote servers and access it through the internet. Instead of using local storage devices such as hard disks, pen drives, or external drives, the data is maintained and managed by cloud service providers, making it easy to access from anywhere at any time. Key features of cloud storage: scalability, high availability, data backup and recovery, cost effective, secure access. Scalability is storage capacity can be increased or decreased based on user requirements without changing hardware. High availability. Data is always accessible even if one server fails because it is stored across multiple servers. Data backup and recovery. Automatically backs up and helps recover it in case of data loss or system failure. Cost effective. Users pay only for the storage they use, reducing the cost of purchasing and maintaining physical storage devices. Secure access. Data is protected using security measures such as encryption, authentication, and access control. Types of cloud storage. Object storage. In object storage, data is stored as objects instead of files or blocks. Each object consists of data, the actual content. Metadata is information about the data, such as size, type, or date. A unique ID is used to identify and access the object. Object storage is highly scalable and is commonly used for storing large amounts of unstructured data such as images, videos, and backups. Second one, block storage. In block storage, data is divided and stored in blocks. Each block acts like a virtual hard disk. Block can be attached to servers and used for operating systems or databases. Block storage provides high performance and is often used in applications that require fast data access. Third one, file storage. In file storage, data is stored as files and folders. It follows a hierarchical structure. It is similar to traditional file system used on personal computers. File storage is easy to use and it's commonly used for shared files, documents, and file-based applications. Advantages of cloud storage: access anywhere, scalability, cost-effective, data backups and recovery, high availability, security, easy sharing, reduced maintenance. Access anywhere is data stored in the cloud can be accessed from anywhere and it at any time using an internet connection. Scalability. Storage capacity can be easily increased or decreased based on user needs without upgrading physical hardware. Cost effective. Users pay only for the storage they use, reducing the cost of buying and maintaining storage devices. Data backup and recovery. Cloud storage automatically backs up data and helps recover it in case of accidental deletion, hardware failure, or disasters. High availability. Data is stored across multiple servers, ensuring continuous access even if one server fails. Security. Cloud providers use encryption, authentication, and access control to protect data from unauthorized access. Easy sharing. Files and data can be shared quickly with others using links or permissions. Reduced maintenance. The cloud service provider manages hardware updates and maintenance, reducing the user's workload. What is resource replication? Resource replication is the process of creating and maintaining multiple copies of cloud resources such as data, virtual machines, or applications across different servers or locations in a cloud environment. The main goal of resource replication is to improve reliability, availability, performance, and fault tolerance. By having multiple copies, the system can continue to function even if one server or location fails. Example of resource replication. Replicated databases in cloud data centers. The same database is stored in multiple data centers to ensure data availability and prevent data loss. Multiple virtual machines running the same application. So, several virtual machines host the same applications to handle high traffic and provide load balancing. Backup servers in different geographic regions. Copies of servers are maintained in different regions to ensure disaster recovery and business continuity. Types of replication. Data replication. Data replication involves storing multiple copies of data on different servers. This ensures high data availability, reliability. High data availability data can be accessed even if one server fails. Reliability is reduces the risk of data loss. It is commonly used in databases, backup systems, and cloud storage devices. Second, service replication. Service replication means running multiple instances of the same service or application. This is used for load balancing, fault tolerance. Load balancing. Traffic is distributed across instances to improve performance. Fault tolerance. If one service instance fails, other continue to operate. This approach is widely used in web applications and microservices architectures. Third one, virtual machines replication. Virtual machine replication involves creating copies of virtual machines across different hosts or servers. It helps in quick recovery during failures, business continuity by minimizing downtime. VM replication is often used in disaster recovery and high availability cloud environments. Next, synchronous replication. In synchronous replication, data is replicated in real time. Every data update is written to all replicas at the same time. Ensures strong data consistency as all copies remain identical. It is so because the system waits for all replicas to be updated. More reliable, commonly used in critical systems like financial applications. Next, asynchronous replication. In asynchronous replication, data is replicated after a certain delay. The main system continues processing without waiting for replicas. Provides faster performance. There is a slight risk of data loss if the primary system fails before replication completes. Commonly used where performance is more important than strict consistency. Next, geographic replication. Geographic replication involves replicating data across different physical locations or regions. Products data against new natural disaster or regional failures. improves access, speed, and performance for users in different geographic areas, enhances overall system availability and reliability. Advantages of resource replication: high availability. Resources remain accessible even if one server or location fails, ensuring continuous service. Fault tolerance. The system can continue operating smoothly when a component fails because other replicas take over. Data reliability. Multiple copies of data reduces the risk of data loss and improve data accuracy. Disaster recovery. Replication across different locations helps recover systems quickly after natural disaster or major failures. Improved performance. Users can access the nearest replica, reducing latency and improving response time. Load balancing. Traffic and workload are distributed across multiple replicas, preventing overload on a single resource. Reduced downtime. Failures cause minimal interruption since replicas are immediately available. Scalability. Replica allows systems to handle increased demand by adding more replicas as needed. Challenges in replication: increased storage cost. Maintaining multiple copies of data or resources requires more storage space, increasing overall costs. Data consistency issues. Keeping all replicas updated at the same time can be difficult, leading to temporary inconsistencies. Network overhead. Replication requires continuous data transfer between servers, which increases network traffic and bandwidth usage. Latency. Replicating data across distant locations can introduce delays in the data access and updates. Complex management. Managing and monitoring multiple replicas across different systems and locations is complicated. Security risks. More replicas mean more points of access, increasing the risk of unauthorized access or data breaches. Synchronization delay. In asynchronous replication, delays in synchronization can result in outdated data on some replication. Resource wastage. Replicas may consume computing and storage resources even when they are rarely used. In conclusion, cloud storage enables secure, scalable, and flexible data management, allowing users to store and access data efficiently over the internet. It eliminates the need for physical storage devices and supports easy expansion based on demand. Resource replication plays a vital role in ensuring reliability, high availability, and fault tolerance in cloud computing systems. By maintaining multiple copies of data and services, replication helps systems continue to operate even during failures. Replication also supports disaster recovery and improves performance by distributing data and services across multiple locations. Although replication introduces challenges such as increased cost and management complexity, its benefits greatly enhance system reliability. Overall, cloud storage and resource replications are essential components of modern cloud computing, working together to deliver robust, efficient, and dependable cloud services. Thank you.